Okay guys, I welcome you to class. My name is Sagala Gash. I want to take you through Riccati differential equations. Riccati equations these are non-linear differential equations, usually considered for MSc students, those pursuing their masters for both applied and pure mathematics. So what exactly is a Riccati differential equation? So if I write an equation in the form if I have dy dx, so if I have dy dx in this form plus, let's say I have bx y to be equal to maybe rx, then we have y squared plus qx. This form of equation is regarded as Riccati. This equation is only reducible by linear first order differential equations, or we can reduce it by Bernoulli differential equations. Usually, to reduce a Riccati differential equation to linear order is more easy than reducing the Riccati equation to Bernoulli equations. So let's say that I let r of x to be equal to 0. So if r of x is 0, if r of x is 0, in this case we are talking of rx times of r of x 1 to be 0. What that means is that the whole of what you have in this particular side, we have the whole of what you have becomes 0. So if that is the case, you will therefore have dy dx plus p of x y to be equal to, now we simply have q of x, because we already know that rxy squared is equal to 0. So with this simply means that we are able to reduce this to linear, and this is linear first order differential equations, ODE. Now if I want to reduce these Riccati equations to a Bernoulli differential equations, then I can let, so if now q of x, if q of x is equal to 0, then dy dx in this case plus pxy rx. When we have the equation in this form, this becomes our Bernoulli. So in this, your Bernoulli differential equation, or what you call it, Bernoulli. So generally we can reduce Riccati equations in terms of first order ordinary differential equations, or we can reduce it in terms of Bernoulli equations. So once we have done that, we are able now to find the general solution in terms of Riccati equations. Usually when you are given an equation that involves Bernoulli equations, the Riccati equations, you will be given some variables Let's say that you are given initial condition. So I can give you. So if you are given initial condition, let's say that the initial condition you are given, in this case, if I take it as 3 of x, we can have equal to y1, in this case as the initial condition, so it is y1 of x. So this is going to be equal to some value. And then in times of linear vector, you will have to use the following. Y must be equal to the initial condition plus 1 over u or 1 over z. So this helps you to reduce the given equation to first order ODE. If you want to reduce to Bernoulli, y, the derivative of that function becomes the initial value plus the derivative of z. So this gives you now Bernoulli ODE. So once you do this, you can now do the third part. The final part will be for you to find the general solution. To find now the general solution. So if you look at these two values here is optional. You can either reduce the Riccati differential equation to linear order by integrating and finding the derivative of this function. Put in the y, which is the initial value, plus 1 over z times of the given equation. Or when you do this, you simply get your first order differential equation. So if you want to reduce the Riccati equation to Bernoulli equation, you simply use y, initial value, plus the derivative of z. The first is usually the easiest and what most able to be tested in times of Riccati differential. But the third part is compulsory, and it is a must that either you reduce your Riccati differential equation to first order differential equation, or you reduce your Riccati differential equation to Bernoulli equation. You must find the general solution. And for you to find the general solution, you simply find the integrating factor. And after finding the integrating factor, you are able to combine the general solution that you have got, because it means now you are going to have a complementary solution and a particular solution. So you add your complementary solution to the particular solution to give you the general solution of the Riccati. So let's take a question and see how we can reduce Riccati differential equations to first order linear